It's Tuesday, June 7th, 2022. I'm Jackson Bird. Today, why is it that humans get so much less sleep than all other primates? And are short sleepers really a thing? Plus, mountains of sugar have been discovered all over the world hiding beneath meadows of seagrass. And bad news for plant parents, new findings explain why plants apparently get super stressed out from physical touch. Here's some cool stuff for your ride home. Did you know that humans get less sleep than any other primate? We average less than 7 hours a night, but according to a recent article in BBC Future, chimps average about 9.5. Ring-tailed lemurs get 11, and three-striped night monkeys get nearly a whopping 17 hours of sleep a night. We humans also apparently spend more time in the REM, or rapid eye movement, phase of sleep. And now you might be thinking, well, other primates don't have all the distractions of electric lighting, blue lights from devices, doom scrolling, etc. They don't have all of that keeping them up and preventing them from falling asleep when they're actually tired. But researchers have studied people living in non-industrial societies, the closest analog to the settings in which we Homo sapiens evolved, and have found they're getting the same amount of sleep as the rest of us. So I guess it's not just Netflix and doom scrolling keeping us up. There are a number of hypotheses about why it might be that we humans get so much less sleep than other primates. And one has to do with when we as a species stopped sleeping in trees. Quoting BBC Future, "Millions of years ago, our ancestors lived and probably slept in trees. Today's chimpanzees and other great apes still sleep in temporary tree beds or platforms. They bend or break branches to create a bowl shape, which they may line with leafy twigs. Apes such as gorillas sometimes also build beds on the ground. Our ancestors transitioned out of the trees to live on the ground, and at some point started sleeping there too. This meant giving up all the perks of arboreal sleep, including relative safety from predators like lions." Evolutionary anthropologist David Sampson laid out what he calls his social sleep hypothesis in the 2021 Annual Review of Anthropology, and he thinks the evolution of human sleep is a story about safety, specifically safety in numbers. Brief, flexibly timed REM-dense sleep likely evolved because of the threat of predation when humans began sleeping on the ground, Sampson says, and he thinks another key to sleeping safely on land was snoozing in a group. "We should think of early human camps and bands as like a snail's shell," he says. "Groups of humans may have shared simple shelters. A fire might have kept people warm and bugs away. Some group members could sleep while others kept watch." End quote. So then you might have people swapping out tasks, catching a nap here and there, maybe evolving a more flexible REM cycle. Now, at least the point about predators leading to less sleep is backed up by multiple studies, including one by Isabella Capellini at Queen's University in Belfast, which found that mammals at a greater risk of predation sleep less on average. But she has a counterpoint to some of Sampson and others' work. A lot of existing research about primate sleep has been done on animals in captivity. Not too much has been done on animals in the wild, and at least in other animals, there has been shown to be a disparity here. A 2008 study of wild sloths found they slept 4.5 hours less than sloths whose sleep had been studied in captivity. Neuroscientist Niels Rottenborg, who conducted that study of wild sloths, says it would really benefit sleep researchers to have more data from wild primates, but he cops that, quote, "Although sloths were compliant with the procedure, I have a feeling primates would spend a lot of time trying to take the equipment off," end quote. So maybe animals in the wild aren't sleeping as much as the ones in captivity, and so some of those numbers I rattled off at the top about how long various species of primates are sleeping are exaggerated from the reality of their wild counterparts. And if they're not actually sleeping so long, then maybe the amount to which humans sleep also isn't so odd. As Capellini put it, quote, "Every time there's a claim that humans are special about something, once we start having more data, we realize they're not that special." End quote. But Gandhi Yetish, a human evolutionary ecologist and anthropologist from UCLA, has an additional take. He agrees on the safety in numbers point, but he says that sleeping in groups may also happen because it's just an extension of how close and in constant contact some small-scale societies are during the day as well. And if indeed ancient humans did this as well, then Samson thinks perhaps part of the trouble sleeping that many people face today could be because we miss sleeping in big groups, a kind of subconscious evolutionary twinge. He also points out that insomnia is like an evolutionary superpower, an adaptive hypervigilance that kept us safe when our ancestors were sleeping out in the savannah. While some people in non-industrial societies today still struggle to get enough sleep, Yetish says that there's nowhere near the conscious effort and attention put into sleep among them like there is in the West. He says, quote, "People are not trying to sleep a certain amount, they just sleep." End quote. So they may not be worried about it as much, but again, they're ultimately getting about the same amount as those of us in larger industrialized societies. Samson and Yetish have independently worked with non-industrial societies to study their sleep, and Yetish says that these communities frequently stay up past dark, conversing and telling stories around the fire. It's not like they fall asleep as soon as the sun sets. They have their evening activities just like we do. And Yetish reframes this as their own version of watching TV or scrolling through feeds. Quoting again, Yetish suggests that ancient humans may have traded some hours of sleep for sharing information and culture around a dwindling fire. You've suddenly made these darkness hours quite productive, he says. Our ancestors may have compressed their sleep into a shorter period because they had more important things to do in the evenings than rest. End quote. This goes along a little with our lengthened REM phase, despite potentially shorter lengths of sleeping. The REM phase is when we experience our most vivid dreams. Part of our evolution as humans is the capacity for more complex thoughts. So both having these longer phases of dreaming and being kept awake because we want to learn more, talk with one another, or be entertained kind of adds up, at least in my layman's interpretation. And by the way, if you're listening to this and thinking about someone you've met before who claims they only need like 4 hours of sleep, I feel like we've all met that person. It turns out, for the people for whom that's genuinely true, not just like CEOs and hustle bros who force themselves to only sleep for 4 hours as a badge of honor, but for people who actually only need a few hours of sleep a night, it's actually caused by genetic mutations. Yinghui Fu from the University of California, San Francisco, and her team first identified in 2009 5 mutations in 3 genes that control how much sleep people need, although Fu thinks there are probably more. Fu explained to Popular Mechanics last week that true short sleepers are able to get more efficient sleep, not just less. They're still getting all the benefits of sleep, but in less time than most people need. There are things that your body does when you sleep. Lots of maintenance, repairing damage, removing waste products. Fu said, quote, "So let's say there are 10 things our body needs to do when we sleep. And what takes 8 hours for most of us, for these short sleepers, it only takes 4 to 6 hours. End quote. And it's not to the detriment of their health. In fact, many of these so-called short sleepers that Fu and her team have studied over the years tend to be healthier, more active, less prone to disease, and live longer. Sound like superhumans to me. I'm pretty jealous, especially as someone to whom a sleep scientist once suggested is a long sleeper, literally the opposite of these short sleepers, people who naturally need 9 or 10 hours of sleep, like those lemurs. Anyways, Fu and her team have found that this same gene mutation that short sleepers share also occurs in mice who are short sleepers. And they haven't cracked all the mysteries about how or why this mutation occurs, but they have at least been able to confirm that yes, some people truly are wired to need less sleep and be perfectly healthy, if not more so. Last week, I talked all about one particular seagrass meadow off Shark Bay in Australia that has turned out to be all one plant, making it the largest living organism in the world. That wasn't the only big seagrass news last month, though. May was a banner month for seagrass. Researchers have found that seagrass meadows all around the world have apparently been hiding mountains of sugar beneath their undulating blades. Seagrass meadows are already pretty awesome. They're carbon-capturing machines, storing nearly twice as much as forests on land within just 1 square kilometer and 35 times faster. Quoting the Weather Network, to better understand these carbon-capturing powerhouses, researchers from the Max Planck Institute for Marine Microbiology conducted a study off the Italian island of Elba, where they took samples of seagrass meadows and their surrounding sediments. Their data revealed that sugar concentrations underneath the seagrass were at least 80 times higher than those found in other marine ecosystems. To put this into perspective, we estimate that worldwide there are between 0.6 and 1.3 million tons of sugar, mainly in the form of sucrose, stated Manuel Libecca, a scientist at the institute in a press release. That's roughly comparable to the amount of sugar in 32 billion cans of Coke. Sunlight allows the plant to capture carbon dioxide from the water and convert it into sugar molecules, which are made up of carbon, hydrogen, and oxygen. And during periods of peak sunlight, such as the early afternoon or summer season, the plants produce more sugar than they need, so they store the extra sucrose around the roots in the sea floor. End quote. And from the researchers at the Max Planck Institute for Marine Microbiology, quote, "Microbes love sugar. It's easy to digest and full of energy. So why isn't the sucrose consumed by the large community of microorganisms in the seagrass rhizosphere?" First author Maggie Sogan said, "What we realized is that seagrass, like many other plants, release phenolic compounds to their sediments. Red wine, coffee, and fruits are all full of phenolics, and many people take them as health supplements. But what is less well known is that phenolics are antimicrobials and inhibit the metabolism of most microorganisms. In our experiments, we added phenolics isolated from seagrass to the microorganisms in the seagrass rhizosphere, and indeed, much less sucrose was consumed compared to when no phenolics were present." End quote. And this finding that the sugar was not being eaten by the symbiotic bacteria in the seagrass was really key because it indicates that the carbon in the sugar stays in that rhizosphere and doesn't add to our atmosphere. If those microorganisms did consume that sucrose, the researchers calculated that 1.54 million tons of carbon dioxide would be released into the atmosphere each year. So, yeah, good thing they don't like it. These microorganisms seem to have a lot in common with those cockroaches from yesterday's show. As the researchers put it, quote, "Seagrass meadows are among the most threatened habitats on our planet. Looking at how much blue carbon, that is carbon captured by the world's ocean and coastal ecosystems, is lost when seagrass communities are decimated, our research clearly shows it is not only the seagrass itself, but also the large amounts of sucrose underneath live seagrasses that would result in a loss of stored carbon." End quote. So this delicate symbiotic relationship between the seagrass and the microbes and the sugars created all play a key role in keeping oceans clean and combating the climate emergency. And really just blows my mind sometimes how many little things in nature have developed in concert with one another towards surviving and even thriving. Although I am sad that the mountains of sugar promised by these headlines isn't sugar that we can ever actually eat without destroying the planet. Forbidden sucrose. Apparently, scientists have long known that physical touch stresses plants out. But I didn't know that. I did, however, know that touching plants is good for us humans and our own health, and now I just feel really bad that I've been going around touching plants to get my own little serotonin boost, and meanwhile, it's been stressing these plants the F out. Although apparently, the stress isn't always a bad thing. Quoting Science Alert, "From knife cuts to animal bites to torrents of rain, every touch that a plant gets leads to a defensive molecular response. Although these responses can be quite varied. They can lead to plants becoming more stress-resistant and flowering later in the year, for example." End quote. Alright, so maybe I am helping my plants be more resilient and grow up big and strong. And while this phenomenon of stressed-out plants has been known about in the scientific community for about 30 years, scientists haven't known why. Until last month. Quoting the Lund University newsroom, "Previous studies have shown that the plant hormone jasmonic acid is an important mediator in touch signaling. It has also been known that jasmonic acid is only part of the plant's complex network of touch-sensitive responses, and that there are several unidentified pathways that have not yet been unveiled." End quote. But in the new study, researchers at Lund University in Sweden exposed thailcress, a popular plant for experiments, having been grown on both Antarctica and more recently in lunar regolith, to soft brushes, which caused thousands of genes and stress hormones to be activated. From there, they used genetic screening to figure out what the cause was. Quoting Science Alert, the genetic screening searched for mutant forms of the plant, ones known to respond in various ways to repeated physical touches. The researchers spotted 6 individual genes that played a role in touch response, 3 for the signaling pathway related to jasmonic acid, and 3 on a separate signaling pathway. That gives biologists a lot more to work with when it comes to understanding how and why this response happens, and gets us further towards potentially manipulating it in the future. We've identified a completely new signaling pathway that controls a plant's response to physical contact and touch. Now, the search for more paths continues. End quote. Knowing these 3 proteins and the signaling pathways will help apply the effects of physical touch practically. Now, it's a concept many farmers have known about without knowing the science behind for eons. One of the researchers points to a centuries-old Japanese agricultural technology in which grain is intentionally trampled during the growing season to promote more abundant harvests. But if we can mesh old wisdom with new scientific knowledge, we might be able to maximize agricultural output even more, or use it to combat some of the extreme weather conditions that will be threatening our food supplies in the future. So, it's probably still okay to pet and hug your plants. It might stress them out, but it's probably good for them in the long run. Alright, well that is going to be it from me for today. This show was produced by Ride Home Media. I'm Jackson Bird, and I will talk to you again tomorrow.